Alright, welcome to lesson 4, using the sine and cosine ratio to calculate lengths. This will be extremely similar to lesson 2 and just a further adaptation of lesson 3. So we're going to find the length RS and RQ to the nearest tenth of a meter. We're going to do this all from using angle S because that is what we are given. There is another way that we could do that by finding angle Q, but we'll just start with the information that we're given. So angle S is equal to 28 degrees. Our side opposite is equal to RQ. Our side adjacent is equal to RS. And our side hypotenuse is equal to 9.6. Now it doesn't matter where we start, so let's just start with sine. So sine 28 is equal to RQ, or X, over hypotenuse, which is 9.6. Now to get rid of this, what we need to do is we need to multiply by 9.6 to both sides, because that crosses here and gives us this value here. So when we rewrite this, we get 9. Why do the smartboard gods forsake me? We get 9.6 sine 28 is equal to RQ. So let's plug that into our calculators exactly as it looks. 9.6, press the sine button, 28, close your bracket, and you should get to the nearest tenth of a meter. 4.5 meters is equal to RQ. So we will write that right here because I'm a huge fan of labeling my diagram as I go, so I know exactly what I'm looking for. Now that we've done that, we can do our cosine. So cos 28 is equal to our adjacent RS over our hypotenuse 9.6. The same process will follow here. It's back. The big chunky numbers are back. 9.6, which leaves us with, when we rewrite it, 9.6 cos 28 is equal to RS. Plug that into your calculator exactly as it looks. The only difference this time that we're using cos, not sine, and we get 8.5 meters is equal to RS. And we write that down. And because we filled in both highlighted sides, we're done. Find the length of the hypotenuse in this question to the nearest tenth of a centimeter. The angle that we are given is angle M is equal to 52 degrees. We know our side opposite is 9.5. Our side adjacent is MP, and our side hypotenuse is what we are looking for, so I'm going to call that X. So we have opposite and we have hypotenuse. We're going to use sine. So sine 52 is equal to 9.5 over X. We are going to cross multiply by setting this up over 1. So that leaves us with this following line of X times sine 52 is equal to 9.5. Now we need to get X by itself because that's what we're solving for. And because I just said we are multiplying timesing by sine 52, it stands to reason that we need to divide by sine 52 to get the value that we are looking for. So that means our line here is going to look like X is equal to 9.5 divided by sine 52. And we plug that into our calculator. 95 divided by sine 9.5 divided by sine of 52. Close your bracket. And to the nearest tenth of a centimeter, 12.1 centimeters. Our next one, we're still looking for our hypotenuse. You can definitely use your highlighter here. Sometimes it helps. We are going to start from angle S. Angle S is equal to 29 degrees. We are given our adjacent of 11.9 centimeters. Our opposite is equal to RQ. And our hypotenuse is the one that we are looking for, so we're going to call that X, and you can even scribble this out because it's not even important. Now we're going to set this up of cos 29 is equal to 11.9 over X. And if you follow these steps from above, you can see that these guys are just going to slide and change places. So X is equal to 11.9 over cos of 29. If you need the steps, show the steps. If you understand what's happening, you don't have to show any more steps than that. To the nearest tenth of a centimeter is 13.6 centimeters. Next question. A surveyor makes the measurements shown in the diagram below to find the distance between two observation towers on opposite sides of the river. So we're looking for this distance here, opposite the river. So we're looking for our hypotenuse again. How far apart are the towers? Well, we have an angle here, so we're going to say angle theta is equal to 73 degrees. We are given our opposite river. Our adjacent is 63, and our hypotenuse is what we're looking for, so we're going to call that x, and we can cross this out so it doesn't throw us off. So we are given adjacent hypotenuse, we're going to use cos. 73 is equal to 63 over x, and because we're finding that hypotenuse, we can do that little hypotenuse slide, we can call it. So x is equal to 63 over cos 73. So that is 63 divided by cos 73, close your bracket, to the nearest meter is 215 meters. And we don't have any other examples. It's off to the practice questions. If you need any help, let me know.